Welcome to our deep dive into Elastic GPU Service or EGS. Imagine if you have a team of data scientists who are all just clamoring for GPU time. It's like a constant battle for resources, right? That's the problem that EGS is tackling head on. And today, we are going to explore how it all works. EGS is the only solution out there that is applying AI and intelligence to solving this battle for GPU resources. So, what is EGS? EGS is the most scalable and efficient GPU utilization platform that transforms your AI ML workflows. So, what's really interesting here is that EGS promises not only to make life easier for data scientists, but also to save a good chunk of money in the process. Let's look at the problem a little more closely. You've got these powerful GPUs sitting there, but they're not always being used efficiently. In this dynamic GPU allocation model as shown here, EGS acts as this intelligent resource manager. It seamlessly allocates GPUs to jobs as they come in, so you don't have GPUs just sitting idle, waiting around. So instead of having these dedicated GPUs for specific models or tasks, EGS creates this pool of resources that can be shared and allocated on demand. Now let's dive into some real-world scenarios with the EGS UI. This scenario involves two teams, a production team that handles incoming inference requests and a development team that's busy testing and experimenting. In a static allocation setup, without EGS managing the GPUs, each team will have their own dedicated GPUs, which leads to a lot of wasted resources. That's what we see here. In this scenario, say the production team has 100 AI models ready to go, and the development team can only run about 20 AI models at a time. So they've got a smaller pool of GPUs to work with. So a total of 120 GPUs are statically allocated for dev and production. But at any given time, the production team uses up to 30 AI models out of the 100 based on usage patterns. So they've got all these GPUs just sitting there idle most of the time. And the dev team is using 20 GPUs for 20 of their test jobs running. So that's a total of 50 AI models, so 50 GPUs being utilized at this time. Thus, we see a wastage of 70 GPUs or a 60% wastage. Further down here, you see those 50 workloads and what type of workloads they are. And there's a neat little heat map here, which shows the utilization of each of those 50 GPUs in use. So when you hover over each GPU, you get specific details on each utilization. So this GPU is 98% utilized. So the cost dashboard shows $24,000 of allocated GPU costs, but only $10,000 of GPU resources being used by both teams. So a wastage of $40,000. Let's see what happens when we flip the switch and enable EGS. Here we see that a pool of 35 GPUs are dynamically shared between both teams as needed. Remember, the production team needs to make sure that they can handle 30 concurrent AI models, so EGS reserves 30 GPUs specifically for them. And the development team needs at least 5 GPUs available at all times to ensure that they can keep their critical tasks running. So that's the total of 35 needed at most. But what's actually running at this point in time? The production team is running 25 models and the development team is running 10. And here's where it gets really interesting. Even though both teams have access to a larger pool of GPUs, EGS is only allocating what's needed at this specific moment. EGS is not just blindly allocating those resources, it's actually analyzing the demand and adjusting accordingly. And the GPU wastage on this dashboard highlights this beautifully. Every single allocated GPU is actively running a workload. So even with those fluctuating workloads, EGS is managing to squeeze out all that inefficiency. That translates directly to cost savings as well. This cost analysis view shows that the total GPU cost for this period is significantly lower than it was with the static allocation model. Every dollar spent on GPUs is actually contributing to running these AI workloads. Okay, how do things work behind the scenes with dynamic allocations? There are views within the EGS UI that show workspaces, GPU requests, and priority queues, and details on AI workloads. Here, in the GPU request section, admins can see all pending GPU requests from different users and workspaces. It's like a central hub for managing all those GPU requests. And the cool thing is that admins can prioritize those requests based on different criteria. Now to the workspaces. EGS allows admins to create these personalized workspaces for individual users or teams. So each user or each data scientist has their own little sandbox within EGS where they can work on their own projects. So we've covered a lot of ground with EGS today. We've talked about challenges of GPU utilization, the benefits of EGS, how it dynamically allocates resources, and even how it integrates with the data scientist's work. Please also go to www.avisha.io to learn more about EGS and our other products. Thank you.